All right, let's look at the homework 6, problem number 26. All right, so this is a ladder problem, so let's look at that. All right, so I already drew a picture. It says that a 13-foot ladder is placed against the vertical wall. So that's a 13 feet long um, and placed against the wall. Right, and suppose the bottom of the ladder slides away from the wall at the constant rate of 3 feet per second. So the bottom end is moving away at that speed. And how fast is the top of the ladder? So this guy is coming down. All right, when the bottom is 5 feet away from the wall. All right, so we need to give variables for changing quantity. Right, for example, right, so you see that distance between the wall and the bottom of the ladder is changing. So I'm going to call this guy x, right, since it's a horizontal distance. And also the height of the top of the ladder, I'm going to probably call that y, right? Then if you look at it, you can see that there is a right triangle here. We can set up equation using a Pythagorean theorem. So Pythagorean theorem goes like x squared plus y squared is equal to 13 squared. So I'm going to just write that down. X squared plus y squared is equal to 13 squared. Right? We don't need a variable for the length of the ladder because it's not changing. It's a constant. All right, so we have that equation. Then, what is 3 feet per second? So this is the rate of change of x with respect to time. So we know that this is going to be dx over dt is equal to 3. And also x is given to be 5, so it's going to be x is equal to 5. And what we want to find is we want to find so how fast the y is changing. So we are looking for dy over dt. All right, so this is what we're looking for. All right, so in order to get the derivative involved, we want to take the derivative of this Pythagorean theorem with respect to t. So I'm going to come down here. Right, so I'm going to take the derivative with respect to t. Right, so you have derivative of x squared would be 2x, right, multiplied by dx over dt. So remember that when you are taking a derivative with respect to a different variable, right? So this is written in x, but we're taking a derivative with respect to t. So we're going to have to use the chain rule. So multiply by the derivative of the variable that's written in and with respect to, in this case, t, right? Then we can do the same thing with the derivative of y squared. So that's going to be 2y, but you would have to multiply by dy over dt. All right, then derivative of 13 squared, it's a kind of a big number, but it's a constant. Derivative is always 0. All right, we have that. All right, so since we're interested in finding dy over dt, I'm going to actually solve for this guy. All right, so first thing I would do is I'm going to move this term over to the right-hand side. Right? We can just subtract the 2x dx over dt. So we're going to get that 2y times dy over dt is equal to negative 2x dx over dt. All right, then we can just get rid of 2y by simply dividing through by 2y. So divide through by 2y, we get dy over dt, which is equal to, so negative 2x dx over dt was already there, and we're dividing by 2y. Right? we can cancel out the 2 on top and then 2 on the bottom. So we end up with negative x over y times dx over dt. All right, so let's plug in the numbers that we already know. So we know that x is equal to 5, which is here. So we can put 5 here. All right, and y is actually we don't know, but we know dx over dt, which shows up right here. Dx over dt is 3. So we can multiply by 3. Multiply by 3. All right, so y value, we can actually find it. We can simply plug x equals 5 into the original equation so that we can solve for y. So you have a 5 squared plus y squared is equal to 13 squared. All right, so we're going to subtract the 5 squared, which is 25. So y squared is equal to, all right, 13 squared would be 169 minus 5 squared is 25, which is going to be 144. All right, then we can just take the square root of both sides to find y. So this is going to be plus or minus. Square root of 144 is, luckily, it's exactly 12. But y is the length. We know that we have to pick the positive one. So it's going to be positive 12 is the value of y. So we're going to put 12 in there. All right, then clean it up. Let's see, you can cancel 3 and 12, and you get 4. So we can see that it's going to be negative 5 quarters feet per second. So the top of the ladder is sliding down at the rate of 5 over 4 feet per second. All right, so let's type in the answer. All right, ladder is sliding down the wall. So since it's already, since already saying down, so I'm not going to put the negative sign, so I'm going to just say 5 over 4. All right, let's check the answer. All right, got that. All right, that's it. I hope that this was clear.